So I will go on with the third part of this lecture, which concerns photosynthesis and biomass structure on the molecular level. The photosynthesis relates to the carbon cycle, which I described in an earlier part of this lecture. So photosynthesis is the process in which carbon is converted to oxygenated hydrocarbon. So carbon dioxide in the air then, and water taken from the ground or also from the air as rain are transformed then to monosaccharides, sugar, by means of the light from the sun. The chlorophyll in the leaves are used as catalyst here in this reaction. And we also have a production then of oxygen. Gibbs free energy is positive here in this reaction, as you may see in this slide, which means that this reaction is not spontaneous. So you need energy for getting the photosynthesis to run. The overall photosynthetic efficiency is normally between 3 and 6%. So it's not so efficient actually. So it's counted on the sunlight which hits the blades, all the biomass with the chlorophyll. And there are several reasons to this low efficiency, that you have some lights which are not absorbed into the leaves and so on. And you also have transpiration in the biomass, which means that some of the energy are used directly in the biomass. If we go into the structure of biomass, looking on a plant and its cells, you can see here the cell wall in the cell, and the lignin, hemicellulose and the cellulose are mainly in the cell walls of the plants, which you can see in this slide. If you look on the structure then, you have both organic and inorganic components of the structure, where the organic components are divided in extractives and cell wall components. We start with looking more deeper into the minerals. You have calcium, potassium, silicon, magnesium, aluminium, sulfur, iron, phosphorus, chlorine, manganese, and sodium. So there are several types of inorganic compounds within biomass. And these compounds are included then in the organic compounds in the plants. Woody biomass have a content of between 1 and 3% of minerals, while non-woody biomass can have up to 25%, as rice husks, for example. Waste also contains a large amount of different minerals, up to 50%. Example of extractives are starch, oil, proteins, and sugar. And these components are not in the cell walls. They can be removed by using solvents during extraction. And these molecules are relatively small. They have a number of carbon not more than 40 in the molecules. Woody biomass have a content of only 1 to 5% of these extractives, while non-woody biomass have up to 80 to 90%, as for example grain. The cell wall components are cellulose, hemicellulose, and lignin. And in wood, these are the main components, where cellulose are the main. Almost 50% of wood contains of cellulose. In wood, cellulose is the primary structural component. It's an organic material, and it contains long-chain polysaccharide carbohydrates of beta-glucose. So it contains only one type of monosaccharide, actually beta-glucose. And you have the general formula of that, as shown here, C6H10O5. In twigs and bark, you have a small content of cellulose, while in cotton, for example, you have a very large content of cellulose. Hemicellulose contains different kind of saccharides, both with rings containing 6 carbons and 5 carbons. So it may contain glucose and cellulose, hexose, and mannose, for example. So that's a difference between hemicellulose and cellulose. The lignin works as a glue between the cellulose and the hemicellulose, and it's an amorph, non-crystalline material. So that was the part concerning biomass structure. Now I will go on with the biomass properties in the next part. Thank you.